All right, y'all. So this is my first attempt at recording with this newer Elmo that I had. So let's just see what happens. Here we go. All right. So this is going to go all the way back to our exponent rules when we first started going over these, and I am going to go through about 3 sets of notes on these for this day. So the first set again is simply talking about monomials, and we did this in foundations. And so you need to know that in order to move on into math 1, but really you've already done this. This is what will be the most simple to y'all, and then as I add other things on, the problem is you're going to start messing these up whenever we learn about the new exponent rules that are going to go into play further down the line. Okay, so again, first time recording with this newer Elmo, so just bear with me. But I did go ahead and fill in all of our definitions here. The monomial is a number or a variable, or it can be the product. Remember, product means multiplication of numbers and variables. Okay, some examples of there are 5x, 3x squared, 9x squared, y7. So again, this is 9 times x squared times y7. So that is the product of those. It's still one term. A solid constant number, -5, -1/2, 2, 7, any of those are also monomials. It is just one term, okay? And basically all you're doing is you are combining like terms. And that's what we did at the very, very beginning of your Foundations of Math 1 classes. We talked about combining like terms, okay? And everybody was pretty good with that whenever we were doing combining like terms, just simply adding or subtracting things that were alike using our exponent rules and simplifying from there. So right here, like 17x minus 25x, y'all would simply tell me the answer is -8x. Okay, and if we had -23y squared and 6y squared, so it's just -23 plus 6, is going to give me -17y squared. We're just combining things that are alike. So remember when we talked about this, we talked about how you can't put x's and y's together. Okay, but you can put y squareds and y squareds together. All right, so let's look at the next one. Okay, so same thing here. You're looking at the variables and the exponents on those variables. And if they are alike, then we can combine them. Okay, so right here, I've got a to the third BC and a to the third BC. So those are alike. So I can say -15 plus 6 is going to give me -9 a to the third BC. So it's just kind of acting like an x there. Okay. 38x squared y minus x squared y. So that's a 1. So they are the same. So it's just going to be 37x squared y. Okay. 2AB and 9AC. Okay, these are not alike. You've got AB and you've got AC. So if they are not alike, we cannot put them together. Therefore, the answer is simply the problem. All right, -8, and we've got MN, 9MN. Those are the same, so that's just going to give me 1MN, or you may just see that written as MN on your EOC. Those understood ones, we've talked about that several times. They are not written, okay? All right, adding and subtracting fractions. I think we did skip this one in class, but I will just hit that real quick. Couple of ways you can do this. You can do 3-step cross multiplication, or you can do common denominator. They do have the same variables, so I'm just going to do my 3-step cross multiplication. So 2 times 3 gives me 6. 5 times 1 gives me 5, and 5 times 3 gives me 15, which is going to give me 1 over 15. So it'd just be 1/15 CD squared. All right, x4, y3 on both of those. So -25 minus 25 more is actually -50 x4, y3. So if you notice, whenever we're combining like terms, all of our variables stayed the same as they were in the problem. Okay, so going back to what we talked about earlier, you can't combine x's and y's. So like y's and z's. So I've got 3y here and 4y. So 3y and 4y is going to give me 7y. And then I've got positive 9z and negative 3z, which is going to give me a positive 6z. And you can't put those together because they are not alike. Same thing here. We've got 12b minus 10b, which is 2b, and there's nothing to combine with the 8a. So there we are. not super good yet, y'all, so you're just going to have to bear with me on my new technology. Okay. All right. 13w squared plus 4w squared is 17w squared, and 9w minus 31w is going to give me negative 22w. And you can't put w's and w squareds together. They don't have the same exponent. They have the same variable, but not the same exponent. Okay. So here we've got 10m squared n minus, remember, understood 1, m squared n, which gives me 9m squared n plus 7mn squared. Same variables, but not the same exponents. So they are different terms. They are unlike. All right. We did skip 13 through 16 in our notes because basically you're just taking it and turning it, find the sum. So we would add those together, find the difference. You would do this one minus this one. Subtract 9a from negative 15a, which means you would start there, just so you know, with negative 15a, and you subtract 9a from that. Okay, so I do want to talk about that terminology. Sum, you know, means to add. Difference means to subtract. And then it says again from negative 9cd squared subtract. So you would start with this one and then subtract negative 2cd squared from that one. Okay. All right. Moving along. All right. So the next topic that we have is going to be our multiplying monomials. Okay. And that's what we call the product rule. All right. So if there is something like this, x to the a, x to the b, basically you're just going to add a plus b. All right. One thing that I do want to mention about that is to make sure, I always say you don't do the same thing to the big numbers that you do to the little numbers. In other words, I'm going to do this kind of over here. All right, just some general examples. Okay, so what this is over here is saying is if you had x to the fourth times x to the third, you would just add 4 plus 3 and get x to the seventh. And you're going to see that like right here, x squared and x to the third is just going to be x to the 2 plus 3, which is x to the fifth. All right, the only thing about the product rule that's written here is there's no numbers here. Okay, if there were numbers here, like if we had a 5 and a 2, then in front you would have 5 times 2. Okay, so in other words, if I had 5x to the fourth times 2x to the third, I would multiply the 5 times 2 and get 10. And then I would still add the 4 plus 3 and get 7. Okay, so you do multiply the big numbers, those are our coefficients, and add your little numbers, which are our exponents. Okay, but you're never going to do the same thing to the coefficients that you do to the exponents. So if I multiply here, I'm not going to multiply up here. All right, they're always different. Okay, understood ones I've taught y'all about are going to be a problem. Write them if you need to. So this is going to be a to the 9 plus 1, which is a to the 10th. This is going to be w to the 7 plus 4, which is w11. Okay, so those are our basic ones. Okay, and then we get into a little more complicated from there. Okay, so again, just using what I talked about over here on the side. All right, so we've got, zoom in a little bit, move it around. Okay, so we've got 4 times 3, which is going to give me 12, and then it's 2 plus 5. So it's 12x to the 7th. Okay, 3 times 5, which gives me 15, and then x to the 6th plus 2, which is 8. Okay, 5 times 6, and then x to the 2 plus 4. So that is 30x to the 6th. And literally, y'all, we're just going to keep going. I'm going to go kind of fast. If you need to stop, pause, rewind, whatever. Okay, negative 4 times 3, and then a to the 3 plus 2, and b to the 1 plus 5. So that's negative 12, a5, b6. And I will write all of these out as I go through this. So -7 times -4, p to the 9 plus 2, q to the 3 plus 6, and r to the 1 plus 4. So that is +28, p to the 11th, q to the 9th, and r to the 5th. Okay? 8 times -3, and then x to the 4 plus 4, and y to the 2 plus 9 gives me -24x8, y11. All right, so here we go. 26 through 28. Okay, multiply. 2 times -5 is -10. -10 times 3, so 2 times -5 times 3 is -10 times 3, which is -30. And then we're going to add 1 plus 2 plus 3, which is y to the 6th. Okay, 1 times 6 times -1 is -6. A is 1, plus 5 is 6, plus another 1 is 7. B is 1 plus 1 plus 1, which is 3. -2 times 1 times 3 is -6. X is 1, 2, 3, 4. And Y is 1, 2, 3, 4, 5. Okay. And I did say I would go through all of these on your notes whenever I did my video. This is going to be a pretty lengthy video because it is 3 sets of notes. But just kind of hang in there, y'all, for this. I am just going to give you the answers to these 3, number 29, 30, and 31. So if you want to try those 3 on your own, you're more than welcome to do that. So it's going to be 42. M is 1, 2, 3. And N is 1 and 4, which is 5. Okay. 8 and 10 is going to give you the 80. C2 and C3 is C5. And D1 and D5 is D6. -4 times -5 is 20. R1 and R4 is R5. And S2 and S1 is S3. Okay. Down here with these fractions, same thing, just using your multiplication of fractions rules. Okay. Basically, I'm doing -6 times 1, which is -6, divided by 2 is -3. So -3 is my number. I got a squared and a to the first, which is a to the third, and b to the first, and b to the first is b to the second. Again, because we're multiplying. Okay, we're adding those exponents. All right, 12 times 2 gives me 24. 24 divided by 3 gives me 8. So I have 8. There's a y1 here and y4, so it's going to be x, y5. You can have the y's first. It could be y5x. It doesn't matter. Your EOC will normally have them in alphabetical order, but it does not matter numerically, mathematically. They're both the same, okay? So 1 times 8 is 8. 8 divided by 4 is 2. So this becomes a 2. 2 times -6 is -12. Then I've got M1 and M2 is M3. N1 and N2 is N3. And that should be my answer. Okay. All right. And then down here, the very last ones that we have down here are mixed practice. And that's where we're going to kind of have to use both rules that we've already talked about. We've talked about adding and subtracting monomials and then multiplying monomials. And this is where it all ties together. Okay, so pay close attention here. So I'm going to start individually. 2 times 4 is 8. 5 plus 1 is x6. 2 plus 3 is y5. 1 times 3 is 3. 4 plus 2 is x6. 4 plus 1 is y5. And now you're going to see that up here, they didn't look like terms. But once I simplified, they are. They both have that x6, y5. So now I'm going to add 8 and 3, which is 11, x6, y5. And the letters, variables, it stayed the same. Okay, it's just like adding 8x and 3x. It's 11x. Okay, but the x6, y5 has to be the same. Okay, so again, once I simplified over here, now I do have the same variables and exponents. So 2 plus -2, that's a 20, sorry. Forgot the 0. Okay, so 20 plus -2 is in fact going to give me 18, A4, B6. All right, so this one's going to stay the same. This one's going to become 12 M8 N8. So 19 minus 12 is 7 M8 N8. And then the last one over here, this becomes positive 15 C5 D2 minus 14 C5 D2, and 15 minus 14 is 1 C5 D2. But remember, those ones are not going to be written on your EOC, so I need you to get used to just seeing the C5 D2. Okay, so we did not do all of those in class on your notes, but that is all those that are there. Okay. All right, so the next paper that we went to, I believe, all right, was our power to a power notes. Okay. And now I don't have our everything filled in up here. Okay. All right, but power to a power is basically when you're raising one base with an exponent to another exponent. Okay, and all you're going to do is you're going to multiply that. It's going to be x to the a times b. Okay, so like right here, these first three are super easy. Okay, I'm going to write it out how you would do it. X to the 2 times 5 is x to the 10th. That's going to go to both. Okay, so that's going to be m to the 7 times 4 and n to the 4 times 4, which is m28 and n16. All right, and then this is c to the 1 times 3 and d to the 2 times 3, or c3 d6. Okay, so that exponent outside, it can't be, well, we don't call it distributing necessarily, because you are going to do a different rule, but it does have to be placed with all the terms that are inside of the problem. Okay, all right, so here we go. All right, right here, you're going to raise the coefficient to the given power. That is different than multiplying the powers. All right, so I'm going to show you this first one, number 4, both ways. Okay, the way that we're talking about is using the product rule, the power of a monomial. Okay, so I'm going to do 5 squared and then x to the 7 times 2. 5 squared is going to give me 25, x to the 14th. But just to show you, okay, just to show you what it could have been. All right, I don't think I have a sticky note around here. TV timeout, y'all. I'll see if I can I'll write it off to the side over here. Okay. If we had 5x to the 7th squared, remember squaring something is the same thing as writing it twice and multiplying, which now is just our product rule that we were using previously. Okay, which means we would do 5 times 5 and x to the 7 plus 7, which gives me 25x14. And if you look, I have the same answer regardless. Okay, the power to a power rule is just a little quicker. Okay, but if you need to use the product rule to write it out twice, then by all means go for it. Okay. All right, so here we go. If I've got this one, it's going to be 2 to the 5th and then x to the 2 times 5 and y to the 1 times 5. So 2 to the 5th means 2 times 2 times 2 times 2 times 2, which I believe is 32, x10, y5. Okay, now be careful here. That's negative 2 squared. You got to square that negative as well, y'all. So that's 4 times 2 and 6 times 2. So that is 4 P8 Q12. All right, this is a 4. It's kind of hard to. Kind of hard to tell, but that is a 4 right there, okay? All right, so we've got negative 4 to the 4th, c to the 3 times 4, and d to the 4 times 4. So negative 4 to the 4th again means negative 4 times negative 4 times negative 4 times negative 4, which is going to end up giving me 16 times 16, which is going to end up giving me 256, C12, D16. Okay. Now that's negative 3 cubed x. All right, so this time it's a cube. So if we're cube, if we got 3 negatives, it's going to be a negative 27 x6. Ooh, fraction. So we're 1/2 cubed, which means it's 1 cubed and 2 cubed, by the way. A to the 3 times 3, B to the 4 times 3, and C to the 5 times 3. So 1 cubed is just 1. Okay. 2 cubed is 2 times 2 times 2, which is going to be 8. And then we're going to leave that A9, B12, and C15. I'll just leave it 1/8 for now. A lot of times they would just put that 8 on the bottom, but we'll talk about that later. Okay. All right, and then these were the last ones that we did, and I don't even again think we did all of these. But we did like multiply here, so that's going to be x to the 3 times 1. I'm sorry, 3 plus 1 because no, it's not. I missed that 3 out there. Okay, rewind, start over. Okay, so it's x to the 3 times 3 and y to the 3 times 3. Let's do that first. Gives me x9, y9 times xy squared. So that's x to the 9 plus 1 and y to the 9 plus 2, which gives me x10, y11. My bad there, y'all. Okay, same thing here. A to the 3 is going to stay there. That's going to be a negative 1 to the 4th, a to the 2 times 4, and b to the 1 times 4. A negative to an even power is a positive, so that basically goes away. We've got a3 times a8, b4, which 3 and 8, when you add them, becomes a11, b4. This is mixed practice where they all do run together. All right, negative 2 squared. You got to use more than one rule. So that's 4a2, b4. This one became 3 squared. So that's 9a4, b2. And then we're going to do 4 times 9, which is 36. And then a2 plus 4, which is 6. And 4 plus 2, which is 6. So 36, a6, b6 there. All right, and let's just jump down right real quick down here to 14. This will be the last one I do. Okay, so 2 cubed is going to give me 8, and then that's a6 plus 3a6. And now we have these the same, remember, y'all, so it would be 11a6. So you can combine 1, 2, 3, several of them, okay, at the same time. Okay, all right. And then the last one that we did on this day was the dividing. Okay. All right, so we did these up here. All right, so for the quotient rule, again, when you divide, you're going to subtract. So we're going to do x to the a minus b. But again, if there are numbers in front, I'll just put it right here, sorry. Okay, so like if you had like 10x5 over 2x3, you would divide your big numbers like it says and get 5, and 5 minus 3 is going to be 5x squared. Okay, these don't have numbers in front of it. It is the rule, but whenever you do that, I just like for you to be able to see an example of that, okay? All right, so here we go. X to the 5 minus 3 is just x squared. K to the 12 minus 2 is just k10. M to the 3 minus 3 is m to the 0. Anything to the 0 power is just 1. Not m, just 1. All right, so this becomes a to the 6 minus 2 and b to the 4 minus 3, or a4, b to the first. Those understood ones, remember, you don't have to write them, but you certainly can. Okay. And then p to the 7 minus 4 and q to the 16 minus 12. So that's p3, q4 right there. Can y'all see all that? Sorry. Okay, so 20 minus 5 gave me x 15. The 9's go away, and z to the first. All right, so here we go. Starting to divide our coefficients, and then use the quotient rule on your variables, all right? So 6 divided by 2 right here gave me 3, and then it's x to the 4 minus 3, so that's just 3x to the first, or just 3x. All right, 14 divided by 7 gives me 2, r to the 2 minus 1, s to the 2 minus 1, so that's 2rs. Negative 36 divided by 4 is going to give me negative 9. And then we've got c to the 2 minus 2 and d to the 5 minus 3. All right, 2 minus 2 becomes a 0, irrelevant, and 5 minus 3 becomes d squared. All right, negative 15 divided by negative 3 is going to give me a 5, and we've got x to the 6 minus 5, y to the 5 minus 3. There's no z to subtract it with, so it will still be part of our answer, okay? So that's going to be x to the first, y to the second, with that z still there. All right, so be careful right here, because 4 over 8 is not a whole number. It does reduce down to a fraction. Okay, so that is 1/2 n to the 5 minus 1. So it can be written like this, y'all, but most likely you're going to see it like that, with that n to the fourth being on the top. And that's what I was talking about earlier, okay? All right, 36 and 54. It does not go evenly, but it does reduce down to 2 over 3. Okay, so we're going to make that a 2 over 3, and then we've got m9 minus 3 and n5 minus 2. So it's going to be 2m6 n3 over 3. All right, so last 4 on this day. So this is one of the longest videos I've made in a while as far as our notes go, y'all, because I don't usually do this many examples in a day, okay? All right, so 3 squared is going to give me 9, and then it's 5 times 2, which is 9x10 divided by 27x3. So then we're going to reduce 9 over 27, and that's going to become down to 1/3, and then we do x to the 10 minus 3, so it's going to be x to the 7th over 3. Seriously, pause it here, work on 14, 15, and 16, and then come back and check. Okay, and then the last 2, so the top's going to stay the same here. This is going to become 16w squared v squared. So 12 over 16 is going to reduce down to us for 3 over 4. And then it's w9 minus 2 and v4 minus 2. So that's going to be 3w7 v2 over 4. All right, again, pause my video right here. Work out number 16, and then come back and check your answer. I'm just going to give you the final answer here. Well, I'll give you the simplified first. So when I simplify up here, I'm going to have 16 C4D 16. Okay, and 4 C, what's the C? C4 D6, which is going to reduce down to 4. My C4s do cancel here, y'all. D10. Okay. All right, let me see if I can figure out how to stop this recording on this new fancy Elmo. And this will be the first one I've done, but this is your exponent rule problems for Math 1 that we did back last, as I was probably a week before last in class. And I'm just now getting around to getting my videos done with all this new technology, okay? So let me see if I can stop my recording.